Bessie is running a race of length k. dk, the maximum is already 1 billion. So it kind of tells you something, right? You don't want to use n log n. You don't want to use n square. Meters. She start running at a speed of 0 meters per second. In a given second, she can either increase her speed by 1 meter per second, or keep unchanged, or decreases by 1 meter per second. For example, in the first second, she can increase her speed to 1 meter per second and run for 1 meter, or keep at 0 meters per second and run for 0 meters. Bessie's speed can never drop below 0. Okay, it's rather straightforward, which is a decision has to make for every second, right? When I see that, you kind of reminds on a small piece of the problem whether or not they have a dependency, right? You still go to that scenario. Bessie will always run towards the finish line. And if she wants to finish after an integer amount of seconds, ending either at or past the goal line at this integer point in time. So basically, let's say at n seconds, basically at n minus 1 second, Bessie has not reached the finish line. But at n seconds, Bessie either hit right on the finish line or past finish line. So that's what we're talking here. Furthermore, she doesn't want to be running too quickly at the finish line. At the instant in time when Bessie finished running k meters, she wants the speed she has just been traveling to be no more than x meters per second. Okay, so you see that there's a restriction here, is that finishing the k distance with the last second, the speed cannot be greater, no more than, can be x, but it cannot go beyond the x meter per second. It kind of set a limit. At the very end, the speed cannot go beyond x. Bessie wants to know how quickly she can finish the race for n different values of x. Well, interesting, right? So you see a user case here is gonna tells you what is the total meters. So here, this is 10 meters, right? 10 meters. And here the x is 5. So basically Bessie is starting at 0 meter per second. And when Bessie running through the finish line, the limitation is that the speed has to be less or equal than 5 meters per second, right? That's what it's saying. And trying to finish the 10 meter as soon as possible. That's what it's asking. And you see here 1, 2, 3, 4, 5. That is, oh, hold on. So, sorry. What is this 5? Output inlines. Okay, the first line contains a k and an n. What is n? Oh, okay. N is basically 5 cases. Okay, you're gonna have 5 user cases. So that's what a 5 means. So this is not right. This is not less than 5 meters per second. So this is 5 means you're gonna have 5 user cases. you're gonna figure out the answers. So the 10 will be total distance. And for the rest of 5 user cases, that defines the limits series, which is less than, let's using x. And try to finish this 10 meters as soon as possible. That's what it's asking. That's what sample output is gonna be, how long it takes to finish. Let's just take one example, then we can think about, is this a greedy problem and why? You see when x equals 1, which is here, you want to making sure when Bessie reached the finish line, the speed has to be less than 1 meter per second, which is clearly saying it has to be 1 meter per second. If it is 0 meter per second, which is a contradiction, right? She will never move. You see how they do? In the first second, increase it to 1 meter. Okay, this is 1 meter. in a second go to the 2 meter. And starting from here is start from here already consumed about 3 meters. Because 1 meter per second takes 1 meter, 2 meter per second to 2 meters, total 3 meters. And then keep speed at 2 meters, travel 5 meters total. So in next is keep at 2 meters in next second. And continue keep at 2 seconds. Sorry, 2 meter per second. And continue keeps at 2. And now you'll consume about 1, 2, 3, 5, 7, 9. Total 9 meters already. And for the last 1 meter, well, speed dropped down to 1 meter. And then totally can, hit the 2 meters. Don't forget the restriction that you can only change the speed by at most 1 meter per second, either go up or go down, slow down or speed up, but 1 meters per second, or you can just keep as same as previous second. That's what it offered. And also the second restriction, you had to making sure the last second, when reach the finish line or pass through the finish line, the speed has to be less than x. So you have a lot of restriction here, 1, 2, 3, 4, 5, and for x equals 1, this is the situation run through. So clearly, how long it takes? 1, 2, 3, 4, 5, 6. It takes 6 seconds to finish the scan, right? You can do the same to try with the other use case. I think for now it's super clear. So let's think about how to solve for this one. Did anyone taking exam for taking this question already? I'm rather interested on your thought while in your exam. In that context, how did you solve this one? All right. Okay. Is it possible you can think of this question as graded questions? Mostly for top 1 graded questions, the question is furnished such as what is minimum, what's maximum. I mean, this one is also talking about what is the minimum time, right? And you can see that in order, let's just think about this. In order to finish 2 meters with a minimum time, we know this, right? I guess everybody finished regular physics. It's not actually required on that level. We know the time equals to the displacement over the average velocity, right? If the average velocity is maximum as possible, you can deliver the minimum time. That's what we know because S is a constant, it's 10 meters. Well, not necessarily, because in the last second you can go through the 10 meters. I mean, let's say around 10 meters, right? It's a fair, first of all. You want to have the maximum average velocity as possible. So that is go. And the second, you're gonna think, well, you cannot just increasing your speed. I mean, if you want to have the maximum speed possible, well, what I want to do if I'm greedy, I'm gonna do this. Every second, I'm gonna grow the speed by 1 meter per second. So this is like a step functions. 1 meter, 2 meters per second, 3, 4, 5, 6 meters per second, right? Definitely, if there's no restriction on your finishing speed, definitely want to do that, right? But with the the limitation on the x, there's a situation that you cannot just go up like this, because at a point if you go down, you may not able to drop down below x meter per second, because same rule applies that every second at most you can slow down by 1 second. So that's a deal. You have a restriction here. And for top 2 greedy questions, as I just mentioned, you had to divide these questions into different cases, and based upon that, and kick in the greedy algorithm. So let me give you the hint on this one, since or anyone has a clue, how are you going to divide the cases? I'm not talking the greedy part. So generally, do you see several cases we can discuss in terms of, let me give you, in terms of the potential range of the limit, for example, the potential range is other variables, for example, and based upon that, how are you going to define the slope? How are you going to define the pivot? Right? You're going to, at a point, let's say, when you arrive to y meter per second, let's say, you had to go down. So from 1 to y, and then from y drop down y minus 1, and go down, go down, go down. Hopefully you land at x meter per second. I mean, that will be a regular user cases. If so, you're gonna think about two questions. Number one, what if it's not the perfect situation that at the last second it just hit the 10th meter? What if it go beyond? Then you do not know the total distance, right? Which is a fair question. The second, how are you going to decide what is the pivot? At what meter per second are you going to start thinking, hey, I need to slow down, because otherwise I will not hit X, right? That would be really fair questions. But before you even try that, can you think of extreme situation? Let me give you the hint. What about the first situation, such as, let's say X is too large to reach? Will be fair, right? X is too large to reach. If you look at this 10 meter per second questions, let's say I'm setting X limitation as 1000 meter per second. Of course, right? There's no any limitation on your choices for every second in terms of speed, because you can go ahead, grow the speed. Because when you accumulate 2 meters, I mean, the landing, the last second, the speed in the last second is way less than X. So it's a fair with the case one, right? When X is too large to reach. And then you're gonna ask a sub question then, well, what is the boundary? What is the boundary for the X? So then, well, for this case one, I can use greedy for sure, because there's no dependency. Then you go back, there's no dependency. The reason is that for every 1 second, for you to go from 0 meter to 10 meter, I don't care what's in front of it. Of course, you have to care. You need to know what is the speed in the last second, and based upon that, you're going to add about 1. But this logic has no change, which means there's no dependency. You just need to go ahead to pick the maximum possible velocity you can pick for that 1 unit. And which implementation here is, you need to add by 1 onto the speed from the previous second, correct? Right? That's case 1. I mean, they're rather straightforward, isn't it? For X is too large to reach, I mean, this one is greedy algorithm. It's gonna be what? So increase speed by 1 meter per second for each second. Simple, right? And then what about the case 2? Clearly, case 2 is you're gonna think about the pivot. You cannot just go ahead and go up to a point and just stop and meet everything. But now let's say X is not too large. I'm rather leaving as to not too large to you to define what. I mean, this is, to be honest, this is just a quadratic function. You can solve it, right? This is a arithmetic sequence. Let's say you go from 1 to y, then what's the sum from 1 to y? It's 1 plus y times y divided by 2, and compare with the 10 meters, right? And just solve that quadratic and solving what is y. And given the y, you can define what is x. That's very simple, but that's case 1. Now, let's go to case 2. So again, for case 2 is, oh, when x is not too large and it needs a pivot. For the second piece of discussion, actually, I also need a technical greedy thinking here. So let's say if the x is not a large number, so basically you cannot just go linear line and hit everything. So the best way, the best way means the shortest time to finish this 2 meter is like this. At the first half, you want to what? You want to grow the speed by 1 meter per second, aggressively, maybe from 1 to y. And let's say this y, and then you go down. You go down from y minus 1, and then y minus 2, and then hopefully at the last second where it's taking to passing the 2 meters, you go down to, that's the perfect situations. Can anyone tell me you can hear me? Because you said my internet connection is bad. Okay, and can still people see my screen? Hello? Okay.
Yeah.
Okay, thanks. Thank you, Eric. Appreciate it. Okay. So for the second case, definitely you want to, the best way to hit the 10 meters, you want to grow up the speed, because in the first half by doing that, you can accumulate a lot of distance or displacement. And then go from the peak speed, you go down, you move down, and just land at the x. That would be the perfect situations you can deliver the shortest time, right? But there's still some corner case you're gonna think of. You may not exactly hit the targets at the last seconds, right? It's still gonna be a situation you're gonna pass through the 10 meters. Maybe you pass through to 30 meters, but still valid. That's why for the second case, you're gonna be a little careful as how you're gonna reason on that. But anyway, there's 2 cases. For case 1, greedy algorithm definitely fit in. For the second one, the greedy algorithm kicking is just in terms of you need to find a pivot. You're gonna take a pivot in terms of the speed distribution to finish the 10 meters. And that will be the structure for these questions for type 2 greedy problems. The rest part is obviously just math problem. But up to here, that's type 2 greedy problems. That is, the given problems, you have to divide it into different segments, which is different cases. And then for each cases, you're gonna justify no dependency relationship. So then you can apply the greedy. On the concept part, I think that's part I want to deliver. But now let's dive in to look at the second case. The first case, I think, is rather straightforward. I'm gonna leave it to you guys to finish. Now, let's look at when x is not too large, it needs a pivot. So let's make some assumption that is this. I'll come aboard a little bit. So let's say the speed distribution gonna be this. So we're gonna increase the speed from 0 meter per second and to where? To y meter per second. And then decrease to x meter per second, right? That's the best situation when lands are right on the limits, right? Based on greedy, correct? There's no other way. Because that's the best way we can have the, largest average velocity, right? So now, let me write this way to help you. 1, 2, 3, 4, 5. Oh, we don't need this number. 1, 2, 3, and onto up to y minus 1, and then y meter per second. That's the first part, right? And to start from there, you're gonna go down from y to y minus 1, and then y minus 2, and go on until you hit the x, right? So, like I said, this is a math problem in terms of this. So pretty much you have a 2-step. And the first step is you can go from 1 to y minus 1, or you can go from 1 to y, whichever. The second step is from the pivot y, you need to drop down to x, right? And for the first step, there are y minus 1 items. This is more like AMC questions now. The second step is y minus x plus 1 items. Well, you tell me what is total distance. The total distance from this one is two arithmetic sequence, right? From 1 to y minus 1, and then from y drop down to x. So very simple, right? The first step is going to be using the first number plusing the last number, y minus 1. So that's going to be y. And times how many total items? That's a y minus 1. And divided by 2. First step, maybe clear. Step 1, step 2, right? And also plus the second step, which is from y drop down to x. Well, this one gonna be what? First number gonna be y, last number gonna be x. You're gonna time how many numbers here? You have y minus x plus by 1 items and divide by 2, right? So that is a total distance. But guys, remember for the second case, you need to define where is the pivot, right? If you do not know what is pivot, how can you possibly know how many numbers? How many numbers from 1 to y minus 1, and then y drop down to x, gonna define how many seconds, and which is the answer gonna return. So you have to figure out what is y. If you get what is y, then you got what is the answer, right? So clearly you have to compare your total distance with what? With the k. Where is the k? The k is the total length. Integer k is 2 meters for this example. So you're going to compare total distance with the k. So here, you can also use in discussion. Here's for the first, let me try not using step anymore. Let's say the first part, you need to find the largest possible y. In that the total distance is less or equal than k. Actually, this is actually a very important step to actually implement this problem. So let me, bear with me, let me explain this. If you find there is a y exist where the total distance equals k, I mean, everybody's happy, right? Then that's the answer. Well, just, you know, linear 1 to y and then drop down to x. That's perfect, right? But not necessarily if you add up the total distance. I mean, the total distance can pass the k, right? Which is also qualify the question that is, as long as Bessie hit the finishing line or passing the finishing line in last second, which is okay, right? So that's a tricky part to define what is a y there for, you know, passing the lines. So here the tricky thing, and also associated with one reasoning I'm going to discuss very soon, is that try to figure out what is a possible y, so then the total distance is less than or equal than k. And that's going to tell you something. And what is a possible y, so the total distance is less or equal than k. Equal to k is good. And less than k in terms of, if you change this one to y plus by 1, and then drop down to y, this is way over. This is a way over, overkill for your reasoning. That's why we want to figure out, just go to the y. So then the total distance is maximally approaching to the distance k, right? Then the reasoning for the next step is this. So if the total distance equal to k, this is the situation I just talked, then the answer is gonna be what? You're gonna return how many numbers from 1 to y minus 1 and y drop down to x. So this is just easy, 2y minus x. So this is simple, right? Okay. And then if the total distance is less than k, and then you look at the difference, which is k minus total distance. First of all, for this DIFF, this difference should less or equal than 2k. it has to be less than 2K. I can tell you why. Here you already define the maximum possible y in terms of total distance is a maximum, but less than k. So if the difference is greater than 2k, think about, you should already capture this situation as increasing y not land pivot at y, but instead of y plus by 1, and go from y plus by 1 and drop down to y. You are adding, you're adding what? You're adding 2y plus by 1. You see that? So that's why the difference is has to be less or equal than 2k. If not, you should already capture this situation from the first step, because you think the maximum possible y has already been defined. You cannot go to y1. That's why the difference can never show than the 2k. That is the reason, right? So this actually is a critical step for boundary. Okay, so yeah, I'm just giving here. So remind yourself what does it mean. It'll be fine. Okay, so since difference is less than 2k, now let's talk about that. So since difference is less than 2k, let's say if difference is less than or equal than y. I'm sorry, what I mean is 2y. If the difference is less than y, what is this? So for the 10 meters, it go up to y and it go down to x, right? And but guess what? This is your total. I'm using t, guys. Total, okay, I know, total. And this is what? This is your k, right? Your total distance. So there's a difference, right? So this difference is DIFF. So we define the diff, right? K minus total, okay. If the difference is less or equal than y, what you can do is whichever, let's say the difference is y minus 1, all right? And then at this step, where the speed is y minus 1, you just need to add another y minus 1 after this step before you increase it to y, correct? So if difference is less than y, whichever, we just need to add 1 more seconds on 2y minus x, because we can match it, because for every step we can keep the speed. If the difference is less than y, because you have numbers from 0 to y to match that difference, as long as it's less than y. Of course, you can also put in here, as long as x is not equal to y. You also can make a match here to match that difference, right? So here, add 1 into the answer, which is at 1 second, right? No, let me say just add 1. Okay, else, if the difference is greater than y, guys, look at this. If you have the difference is greater than y, definitely gonna less than 2y, then that's a whatever number, let's say it's a y plus by 2. How about that? To match y plus by 2, you cannot just use 1 second to match it, right? Because your candidate just go from 0 to y and y to x. And you can definitely break down y plus by 2. You know, for example, maybe I can break down to y meter per second and 2 meter per second. For this 2 meter per second, I can make a match here. And for this y, well, I can make a match here. You just literally add 2 seconds into the answer. And since the difference, the boundary can never go beyond 2y. So that's why for the second case, you have to add 2 into the answer, correct? So with that being said, this problem has been done mostly. So with that, you just discuss, right? I mean, this is, like I said, is already problem already. And based on that, you add 1 or 2 based on the 2y minus x, and accordingly. So 2 parts I want to deliver for this class. Number 1, this is type 2, second type of greedy algorithm. You need to justify why for each step. Of course, we talked already. The second step is actual implementation, especially for this part. The logic we make is trying to figure out the largest possible y, so then the total distance is the maximum, but less or equal than k. And with this, so then we can define the restriction on the difference, where is a k subtract by total distance, and which is going to be less or equal than 2y. With this boundary, we can have two different cases or scenario, which you just need to add 1 more second or 2 more seconds into your answer, so that can deliver the whole questions.